So we have a couple of people out. We're going to do a sample. Right. So we have been working for the last couple of days on solving equations. If you guys have your homework for me, I will take it. Your cute little, and I want your pictures if you get a picture. Is that all right? Homework, guys. Oh yeah, that's right. So I hope you guys did yesterday. There it is. Anybody else? I got Annabelle and Josh and Corey. Okay. All right. I don't want your attention divided. So if you're not done with the homework, don't be doing it right now. I need your full attention on what we're doing at the moment. And if you need to finish your homework tonight, or if we have some time at the end today, we can work on it then. I do need all of yours. Okay, so what we're doing today is we are giving you another tool to be able to solve equations and to condense expressions. We have talked about the rules of exponents, what you do when you have, for instance, x to the fourth times x to the fifth. Who remembers what we do with those exponents when it's written like that? Yes, you add them. So explain why that is. Why would I have x to the ninth equal to x to the fourth times x to the fifth? What does an exponent mean? Let's go that direction. When I say 2 to the third power, what am I really saying? Three 2's being multiplied together. 2 times 2 times 2. That's what 2 to the third means. So if I have x to the fourth, that's 4 x's being multiplied together. If I have x to the fifth, that's 5 x's. 3, 4, 5. All together, that's 9 x's being multiplied together. That's why we're adding the exponents. That exponent tells you how many of those things are being multiplied together. So what if we're doing division? Now we're subtracting, because this is like, got 6 x's, and we're dividing that by 2 x's on the bottom. 2 of those guys are going to cancel out. That's why we're subtracting. That would be 4 x's being multiplied together is the result. So, and then the last one here, the product property, which we already are the power property, is when you have a set of parentheses and we're taking whatever that exponent is, that exponential statement, and we're raising it to a power. So this means I've got x to the fourth, another x to the fourth, another x to the fourth, another x to the fourth, and another x to the fourth. 5 of those x to the fourths being multiplied together. So what's our power on that? 4, 8, 12, 16, 20 x's being multiplied together. So if it's written like this, with an exponential and then it's raised to another exponent, you're multiplying those exponents together. So we should get x to the 20th. That's a 0, not a 5 with 6. X to the 20th. Okay. All right. So we're going to take those and we're going to go kind of the other direction with properties of, let's go ahead and fill in what I missed up here already. Opposite inverse of exponents. Inverse of exponentials. This is what our logarithms are going to be. So if we were adding here, what do you think we're going to do with the of numbers here? Think about it. Nope, not subtract. This is multiplication, and I added the exponents. Now I've got addition. What do you think I'm going to do with the other one? Multiply. We're flipping it on its head. Thank you. So we're going to have the log base A just gets written once, and we multiply the other numbers. So for exponents, for multiplications, we add the exponents. For logs, for addition, we multiply the other numbers. Okay, so this is going to be log base A of 20. Remember, logs find us exponents. So when we are adding for the logs, we are going to multiply the other numbers. So what do you think is going to happen with the quotient property? If I'm subtracting two logs, what do you think I'm going to do with the numbers? Good, divide them. What is 6 divided by 2? You want to make yourself a note? Of numbers. I'm writing it that way because that's how you say it. We say log base A of 4. So if it's quotient or there is, oops, that's not right. For subtraction, we divide the others. Sorry, brain is not working as fast. For subtraction, we divide the other numbers. For addition, we multiply the other numbers. So what are we going to do with the product? There's a little difference. Let me show you this first. So anytime you have a number that is in the front being multiplied with a log, we can rewrite that with this guy becoming the exponent. So the 2 gets stuck on top of the 8. It looks like this. Log base A of 8 squared. That's going to be really helpful when I'm trying to get down to just a log. Okay, you'll see what I mean when we get into multiple logs together. All right, let's try these problems. Okay. So I've got a log with the same base, 2 logs with the same base. First thing you know is that you are only going to write that log and base one time. So let's go ahead and do that. Log base 3. That's the only time I'm writing that. Okay, Jayon, what am I doing with the 8 and the 2? Correct. So what's it going to be? Log base 3 of what? I want you guys to go ahead and try 2 and 3. You can count when you have both of those done.
There ever be like a chance of the log being different? Like you know how such log will.
You're talking about the base? I'm never going to have you do logs with different bases in the same problem. Good question. That could happen. And if that's the case, then you can't do what we're doing. The log and base have to be the same in order for us to use this product of power or quotient property. Any of those. Good question. Yes. Because I left my good glasses at home today, so. I'm gonna do my best to see the numbers. Oh, whoops. Was that a 5? Okay, all right, cool. All right, very good. So, this number here, so this number is 2 and 1. You see a plus, between the two. That's it, that's the base. Base hits, that stays there no matter what, so see how this goes on base of 4, you got that, yeah, perfect. 16 came from the 8 times 2. So that's what you're doing. Yeah. Okay, same thing with that one. Let's go the first. All right. This one's the same. There's an X there, but it doesn't change it. What's it gonna be? 40. Give me the whole thing.
Oh.
Log.
Well,
Base 7 of 8x. Now, you're not going to see this every time, but I think it's more correct if you write it like this. Whenever you have more than just a single number, there's a number, there's a variable. I want to put it in parentheses to show that that log belongs to both of those things. It's not log base 7 of 8 times x. It's log base 7 of 8x. See the difference? So anytime you have more than just a number without a variable, put your answer part, your of part in parentheses. Okay, what about 5? What do you get when you multiply 5 times x minus 3? London. Yeah, so we're going to write the log base 8 first. And in parentheses, we get 5x minus 15. We just multiplied the 5 times the x and the negative 3. That's distribution. Okay, what if there's 3 of them? It's fine, we're still multiplying. Filling, what's 6? Base 6 of what? Where you go with numbers? What have we done with all of them so far? Multiply. There's 3 numbers, but it's still multiplication. It's all addition through there. So we're still using the product property. What's 2 times 3 times 6? There we go. I'm going to leave it that way. There's some of these, well, most of them, unless it's got a variable, we really could go one more step and say log base 6 of 36. 6 to what power is 36? That'd be 2. 6 squared is 36. So this could be simplified down to 2, but I'm stopping there just so, we can see what's happening with the property, whatever. So yes, if it asks you to simplify completely, we would go one more step on that. Number 6 will be equal to 2. Okay, what about this one? Josh. Of AB. Put it in parentheses so we show that the log is of both of those variables. Good. All right. I don't love the way 8 is written just because one of them gets a big letter and that's confusing, but pretend like it's just normal. Log 12 plus log x plus log y. What's different about this one from the other ones that we've looked at so far? You don't see the base, but we talked about this on day 1. What if there's no base showing? The base is 10. It's a common log. You don't need to write it in there, but just realize that that's what that means. So we're still multiplying all the of numbers together, right? Well, XY. We just condensed into a single logarithm. Okay, Addie, what's 9 going to be? Log base 3. What's in the parentheses? And? Yeah, this one, you got that one? What about that guy? Yeah, I'll read them. Okay, my ABC is up a little ways. It should really be at the same level as the log. It's not an X. Let me rewrite this. Base 3 of A, B, C. Okay, we clear on the product property? Right, let's do the quotient property. Okay, same thing, only now we're gonna have division. Okay, guys, don't get freaked out because it looks like fraction. Still just the same as what we've been doing, only now it's division. Log of what? Somebody give it a try. Perfect. Exactly. So if you see subtraction, you're gonna end up fraction in your of spot. Okay. All right, Jayon, what's 11?
You step back into
Oh my God.
um A/T.
Okay, can you simplify that for me? What's 8 over 2? What's 8 divided by 2? I don't really need the parentheses on that because the fraction is simplified down to the whole number, but it's not wrong to put it that way. Yeah, well, it is a fraction, but when I've got whole numbers over whole numbers that simplify down, I'm gonna go ahead and say what I ended up with. Let's go ahead and write to the side of this how we got there. Log base 3 of 8 over 2. Yep, and that's how we ended up with the 4 instead of parentheses. Do the same thing on 12. This one will simplify down too. Let me see what you get. When you're done, check with the person sitting next to you, nearest you. See if you guys got the same thing. I'm gonna wait until everybody's checked with somebody sitting near them. You got the same thing. Go ahead and try the next line down. 13, 14, and 15. If you didn't get the same thing and you can't figure out why, raise your hand and I'll come in and check, see what's going on. Addie, did you check with somebody? Okay. Base? Checked. Okay. Josh, did you check with somebody? Okay, please. Good. Very next thing. So that's. Yep. Yep, okay, now, while you guys are working on that, let me just point out. Signs belong to whatever comes after them. This is gonna become really important as we get into the more complicated things that we're gonna be simplifying. This minus sign right here belongs to that term. So the 2 is the part that goes to the bottom of the fraction, right? Nobody made a mistake on that. I can see everybody was dividing 42 by 6 to get 5 on number 12. On this one, it should be A over 2. The A is a positive term. There's no minus sign in the beginning of the log that has the A on it. So the A would end up on the top. The 2 would end up on the bottom of the fraction. It should look like this. Base 3 of A over 2. So just remember that when you're reading, we do this left to right, just like we do words and books and whatever. Whatever comes in front of a term, that sign is what belongs to it. Okay. So let's see. Days, what'd you get for 14? Oops. Of what? Oh. Base 9 of. Okay, this one should have been similar. Log base 5 of 7. What's the last one? Log base 2 of 8. 24 divided by 3. Any questions on this? Is there any difference between how I wrote this one or how I wrote that one? 12 and 14? Yeah. Does it matter? On this one, no, because there's only one number. So I can write it with the parentheses, but it's really not necessary. So, and you're going to see that some of these don't. Oh, maybe not today. Well, we'll get to that one. All right. This is where it becomes important that you pay attention to whether there's a plus or a minus in front of the term. The ones with the minuses are going down to the bottom of the fraction. The ones with the pluses are staying on the top. Sometimes there's going to be more than one in on the top or on the bottom. So, Jan, is that 4 going to be on the top or the bottom of this fraction that I'm creating? Top, good. Log base 5. Oh. Make my 5s different than I'm used to making them. How many of you guys, when you make a 5, start here and then go back and cross it? So you guys start here, go like that. It's a better way, especially when you're working on a whiteboard like this. So I'm trying to do that. Log base 5 of 4 on the top. Okay, that's what you guys told me. Where's the 3 going? Top or bottom? Top. This one has a plus in front of that term. Even though that minus is right next to the 3, it's not in front of it. So the 3 is on the top, being multiplied with the 4, right? Okay, where's the 6 going? On the bottom. Okay, so let's simplify that. Go ahead and put that whole thing in your calculator. 4 times 3 divided by 6. Get a whole number, great. If you don't get a whole number, we're going to change it into a fraction by hitting math, enter, enter. Think you're getting a whole number on this, are you? What you got, 2? Okay, so this simplifies down to log base 5 of 2. Try number 17. If you can, simplify them, yes. Okay, down, what's done? Down, what's good?
0 times multiply 603 and then 205.
Okay, what does it end up being?
I didn't.
Okay, simplify what's in there. I think he's right. Do you guys agree with how he stuck it together? Excellent. Okay, find out what that simplifies down to. What's 6 times 3 divided by 2? All right, some mental math right here. Without putting this in your calculator, give me an estimate for what the answer for that would be. If I were to evaluate this, what would log base 4 of 9 give you?
There's more solving.
What does a log find you? They find you exponents, right? So the question is,
Oh, 9 4 times.
4 to what power would give you 9? Give me a guess.
That's like 4. No, I'm not saying that.
What'd you say? 2.5? The other guesses? Any other guesses?
That ain't even possible. Oh,
You're gonna say 2.5? What were you gonna say? 2.5? Any other guesses?
2.
Okay, so 4 to the first power is what? It's 4. What's 4 squared? Oh, so we went too far. 9's not quite 16. Okay, now do it. Log base 4 of 9. We're just taking a little detour. This isn't really part of the lesson today, but I want you guys to understand what you're working with. Go ahead and put it in your log base 4 of 9, and tell me what you get. Adding the 2. Go ahead, put it in log base. Really? Because I can't do it in my head. That's amazing, Jan. What'd you get? 1.58.
4 5.
Okay, so some big long decimal, but somewhere between 1 and 2. Because 9 is between 4 and 16. Okay, sorry, side note. All right, last one on this row. Log base 3 of 10 plus log base 3 of x minus log base 3 of 5. Raise your hand when you have it all simplified and you think you're good.
You have to put 10 extra. Can we just put 10 with the x basically?
No. The x is not a 1. Very common mistake. The x is whatever number I decide to make it. It's a variable. It could be a 2. It could be 732.
So what number are you making it?
I'm not making it any number. It's a variable. It's going to stay a variable. And yes, you need it.
So it'll be 10x, right?
10x on the top, yes. This is what Jayon has told me so far. This is what we have. I've at the bottom. How does that simplify? To x. Good. Don't ignore the variables. They matter. Perfect. All right. Last property, power property. Okay, power property, like I said in the beginning, whenever you have a number in front of log, right in front of it, not separated by a plus or a minus, but right in front of log, that guy is going to become the new exponent on whatever the log is of. Log of x. All you're doing. What's the base on this? 10. Good. All right. What am I talking to today? Bianca, what's 20? Nope. Where's the 4 go? Help her out, Annabelle. X to the 4th. So this becomes the new exponent on that guy. Doesn't look like an arrow, but bear with me. X to the 4th. He is now an exponent on whatever the of part of the log was. Okay, good. All right. Same thing's going to happen here. and then we're gonna combine. So this one's gonna be a two-step problem. Let's start with making your coefficients, make the coefficients exponents on the other parts of the logs. Start it out, somebody.
Log 5,
Base 5,
x
x to the 4.
plus log 5,
Okay, good. Now I can combine. I can't combine into single logs until my coefficients are gone and I've just got log this, log that. So now when I plug them together, I'm gonna have log base 5 of x to the 4th, 5 cubed.
You would just roll the same thing, but you shorten it.
Yes, exactly. That's the whole idea. Condense into a single log. That's what the problems will ask you to do. Take this big long thing and condense it into a single logarithm. That's what we're doing here. Okay, what's the only thing we have to move on number 22? The 3. The 3 is going to become the exponent on the x. We're going to log base 2 of 12 plus log base 2 of x cubed. Okay, condense it into a single log now. What? Plus. Actually, really glad you said that. Once we combine, we are not adding, we are multiplying the of numbers. So 12 what? That's good. No plus in there. That is a really common mistake. Good job. Okay, let's see you guys do number 23 and number 24. When you have it, raise your hand. I'm gonna come check. You actually should be able to do the rest of them now, right? These.
I think we should.
Yeah, all the rest of them. We've learned everything we need to learn. I want you guys to go ahead and, oh, there's that stuff in there. What? Well, I'll give you a hint. I haven't done anything with radicals today, so you can probably eliminate those choices. That would only be if you had a power of like a fraction. We didn't deal with any powers of fractions. So yes, you should be able to do all the rest of them. Go ahead and get done with 23 and 24. Let me check. And then if I say you're good, you can go ahead and work on the rest of page 2. Oh, make an effort on the first couple though. Make an effort on 23, 24, and let me check. And then yes, of course I will.
So I hope,
I'm giving answers. This is called guided practice.
we feel like it hands on.
I know. It's always so sad. You weren't here on the day that we did the building of the equations, or were you?
That was it.
Yeah, Wednesday. You would have loved that activity. This one's okay. Oh wait, that's minus. It says we should have a function. There's minus, so should we have something in the denominator? With this one. Well, what's after the minus? Oh wait.
Log one.
You're only one? Okay. When we condense into a single, oh wait, are we doing the in-between step? We're doing the fourth. I'm gonna do this part. We gotta move this first. It's a two-step problem, right? We have to move the coefficients first and then condense.
So x will.
X to the 4th. Yeah, that one will have an X to the 4th. Oh, I'm just like that one. There. There. simplify now. 6 divided by 3 is 8. Anybody else ready to help me check theirs? That's not me. Okay, the 5 is the base. This has to be the base. Base is not going to so that 10. So I see you try to do this. You try to do this from this side. Yeah, like this. And become the exponent. Okay, seeing enough confusion, I think, that I'm going to show the first couple. Actually, which one? This one. Let's work with 26. This 26 might be a little more difficult than the other one, so let's try that one together. Where's the 2 going? The first 2 in front of log. What? Log base 5, yes. Of what? This first term, log base 5 of what? 2 goes to where? What does it become? Not behind the 5. On the 3. It becomes the exponent on the 3.
So why just keep this?
Because that's a base. It's the base. The 2 becomes the exponent on the of part of the log. Okay. So log base 5 of 3 squared. Okay. Where's that 3 going? Let's change colors. Okay, now we got still a log base 5. Okay. And the 3 goes where? On the 2. It becomes the exponent on the 2. 2 cubed. Okay. All right. This one doesn't have one, so we can just write him down. He doesn't have a coefficient, so we'll just write him down as he was. And now, we're going to put it into a fraction. That's our next step. Sure, do that. But, oh, you're talking about right now? And while it's got its separate log? No, because that's only for once we condense. Once we combine into a single logarithm, that's when we're using the quotient property. That's when the fraction gets created. So we're going to write the log base 5 only gets written once in the front. We're going to have a fraction. Where is the 3 squared going? On the top. Where is the 2 cubed going? On the top. Where is the 4 going? That's your look. Now, these are all just regular numbers. There's no, or not regular, they've got some exponents in there, but they none of it has variable. Can we simplify this? What's 3 squared? 9. What's 2 cubed? It's okay if you don't know right off the top of your head. 2 times 2 times 2 is 8. So we have 9 times 8 divided by 4. Figure out what that is. 18. So our final answer on this will be log base 5 of 18. That was the first one up there. We want to come to the board and do 27. Okay. Does anyone want to do 25? Show 25? Okay, while you're working, I'm going to go ahead and show you guys 23 and 24. Double check yours, make sure they work. This one is a common log. It doesn't show the base. Just remember, when they do show the bases, we are not putting the exponents on those. We're putting the exponents on the of parts of each log. Okay, so this 4 goes on the x. 5 log of x to the 4 log of y. Now Now that we've gotten rid of the coefficients, we combine into a single log. That's an log, sorry, my crazy little tail on that guy. Should be 5x to the 4th over y. There's nothing to simplify on that. It's a bunch of variables. There's no number to simplify with the 5, so you're finished right there. How many of you guys got that one right? Raise your hand if you got 23, 100% right. Is it because you didn't try it, or where do we make a mistake? Oh, okay. Yep, watch that. Sometimes I've seen kids do this, and for some people this works really well. When you begin looking at these, make yourself a notation. This guy's going to go down. This guy's going to go down. This guy's going to go down. This guy's going down. That guy's going down. What did you ask me?
Which one did you want me to do?
You're doing 27.
Oh.
Or whichever. I don't really care. You want to do 24 or 25? Any of the numbers that you like. Okay. Yep, we're going to start log.
I didn't even have a number.
You're right. So that's a common log. We don't need to write the base on that guy. No, just leave it. You can write a 10, but if you don't write the number, it's an implied 10 anyway. All right. Oh, wait. Where's the 3 come from?
Oh, no. It's supposed to be a 2.
Okay.
Oh, no.
Good. Took his coefficient of 2 and made it an exponent on the x. Good. Where's the 4 going? Up or down? Okay.
I just put the board on.
Yep. It's hard, isn't it? I like when you guys come to the board, you appreciate me more. All right. Okay, check it. Is that what you got? Good. If you wrote the 4 in front of the x squared, that would be okay too. Doesn't matter the order. Normally we do see the numbers or the the ones that are not variables. We usually see those in front of the variables, but that is perfectly fine. Anybody want to try number 24 or 25? Number yourselves today? Bye, have fun. Okay, so we're going to take our exponents or our coefficients and make them exponents. That goes in with that one. That's the only one we have. I have one to move. We're going to get log base 5 of x squared. Looks like I've got a 6 up there as well. And on the bottom, I have the 3. This one can be simplified. 6 over 3 is 2. So this is the same as log base 5 of 2x squared. Okay. Do something different? Okay. Okay, give me a up, middle, down. Where are we with this? Third away from between up and middle. Okay, right. Down good? Where you at?
I have a question.
That tells me right there. Same middle. Okay. Yeah. No, it doesn't. This could be 3x squared or x squared 3. Usually you put the number and then the variable, but But it's not wrong to write it the other way around. Okay, there are 4 multiple choice problems on the bottom. I want all 4 of them done before the bell rings. That is your only assignment for today. No homework. Unless you didn't finish your little turkey thing, then that's homework. No? What's the minus? That's for the minuses.
This isn't real probably one for you. I don't know where they got that Z from.
Exactly. Well, that ain't it.
Why did they put the one with the person out?
What's on the minus? Nice. Yep, what's that? Name on it? Okay, so like I said, if you didn't already turn in your homework from last night, as soon as I take up this one, get that out and be working on it. So you are done. No. Let's start with this. Or about one more. And then go, we can finish this later. Yeah. I did it in homework, and you know, about four. And all these guys are here, where you're getting this. Anytime you have a number right in front of the eligible football, yes, actually show this. This can come here. Put it together. Yeah. This one, I have a picture of that too. Right, the little rainbow.
You all know about the coding.
It's a little too far. We don't pass a plus or minus. So it's gonna land. Okay. Does that make sense? Not really, but. So now look through your possibilities here. Which one of them has an age? Maybe which one? Look for that. That'll be your first giveaway. Selection choose. So, yeah. Yeah, do that with the rest of it. And yes, no. Try 31 again. Pay attention to the pluses and minuses. Up today, people. So, just a heads up. The reason we did what we did today was so that we can do what we did yesterday. With expressions that start, with equations that start like this. Remember how we were using a base to get rid of a log? Well, we have to have a single log to be able to do that. So now you guys have the tools in your tool belt to solve even more complicated equations. things that have more than one log, you can put them together and then get rid of the log by taking the base on both sides. So excellent progress. Yes, sir. That's right. Anybody have fun plans this weekend? That's cool. What are you gonna do? Gonna look a lot different?
I've been trying to like